Hello students, welcome back to maths class. Today we will start the calculus part. I stopped the geometry and now we are in calculus. Actually in geometry some more topics are there, parabola, hyperbola, ellipse, but I started this calculus. So after dealing this integration, again we will go back to parabola and hyperbola, ellipse. Three topics are there. This is major topic and this is calculus. So already I said to you while dealing in first year, calculus is just like a father for mathematics. It plays very key role in mathematics and for your higher studies also. Not only in intermediate, in degree and in engineering, you are going to get all these basic points. Okay, so don't neglect and be attentive. Actually, whenever if I start any topic newly, you should be attentive throughout the class, at least 2-3 days, then you will get used to that topic and you can move smoothly for the remaining chapter. So here integration means it is a reverse process of differentiation. First year we gone through the differentiation, right? So it's a reverse process is different integration. In calculus we are having two parts. One is differentiation and the second one is integration, right? So differentiation we completed in first year. Now we are dealing with integration. So exactly reverse process of differentiation is called integration. Okay, so what is meant by integration means, see, the function f of x is said to be antiderivative of f of x if d by dx of f of x is equal to f of x. Madam, what is this? Just you are reading? No, it is not reading. So a function, this one is said to be antiderivative. I said no, integration is a reverse process of differentiation. That's why we are saying antiderivative for this, right? So reverse of derivative, that's why antiderivative. So f of x is said to be antiderivative of the function f of x if d by dx of this function is this one. So I will give one example. D by dx of sin x is equal to cos x, right? So d by dx of sin x value, you know it very well, cos x. Then we can say that this sin x is antiderivative of cos x. Already we gone through all the differentiation. Even in dealing this integration also, we will need all the differentiation formulas. So once again, you open your first year calculus notebook and go through the differentiation formulas. They are needed, right, to solve these problems. That is the basic thing. Entirely integration is a reverse process of our differentiation. Okay, so come on, d by dx of sin x value is cos x. Then we can say this sin x is antiderivative of cos x. If we take a collection of all antiderivative of a function, then it is called integral of that function and it is denoted by like this. So it is a symbol for integration. In differentiation we will write d by dx for each and every problem. Here we will write this symbol. This symbol represents the integration of this function with respect to x. That's why for each and every function we have to take, suppose if we want to find the integral, we have to take this symbol. This is the symbol. Just squeeze, stretch your s. Right girls, this is the symbol for integration. Integration of f of x dx. So what is its formula? Integral of f of x dx is equal to f of x plus c. This is called antiderivative. F of x is called antiderivative and c is called integral constant. For each and every problem at the end of the answer throughout this chapter, we have to write plus c plus c plus c. Right, that is integral constant. For each formula plus c will be there. So after solving the each question we have to write plus c there. So remember, once again we are dealing integration, very big topic, 18 marks topic this one, right? You are going to get 2 7 marks questions, 2 long questions and 2 very short answer questions. That's why I have given as 7 plus 7 plus 2 plus 2. Okay, 2 long questions, 2 very short answer. Totally 18 marks are there for your integration. And this integration is a base for the next chapter. Definite integrals is there. If you know integrals, you can go for definite integrals. Again, one more topic is there, differential equations. There also the entire thing will be depends on this chapter. So this chapter starting, this is entirely new for you. Till now you didn't get anywhere in this, any class you don't get this topic. Now only you are getting. This is new topic, but if you show interest, it is very scoring also, and for your further studies, higher studies, this is must. You have to learn, then your higher classes, degree and engineering will be easy for you. Okay, so get ready for this integration. So come to the definition. What is integration? Integration. Before going to integration, first we will go to the definition of antiderivative. What is antiderivative? The function f of x is said to be antiderivative of the function small f of x. Here I have taken capital F of x. This function is said to be antiderivative of this function if d by dx of derivative of this function is equal to another function. Derivative of this function is equal to this function, then this is said to be antiderivative of this function. So antiderivative, I said integration is a reverse. So anti of differentiation, isn't it? Integration is reverse process of differentiation. That's why we are saying antiderivative here. Okay, so I have given one example also. D by dx of sin x is equal to cos x. You know it very well from our first year knowledge. Derivative of sin x is equal to cos x. So then we can say this sin x is antiderivative of this cos x. Okay, so this is the example for antiderivative. D by dx of this function is equal to this one. So it is said to be antiderivative of this function. If we take collection of all such antiderivatives, then that is called integral of the function, and it is denoted by integral of the function f of x. And how we will write integral of that function means we can write this as integration of f of x dx. Okay, so we have to take this symbol, and after each function, f of x means what is the meaning? Any value in terms of x, any, yes, function in terms of x, f of x means any value in terms of x is called f of x. So after this compulsory we have to write into dx. Okay, so for each and every problem, integration, find the integral of means we have to take this symbol. We are finding integration with respect to x, that's why into dx will be there. And what will be its formula? Integral f of x dx is equal to capital F of x plus c. So this is called antiderivative, and this c is called the integral constant. What is c? C is integral constant. Okay, so now we will go to some standard formulas in integration. So slowly you will get used to all these formulas. Don't take stress, don't take strain, pressure on you by seeing so many formulas are there. Not like that. Slowly by applying, right. So this is lengthy chapter also. At the end he will be perfect with the formulas. Okay, so come on. First formula is integral dx is equal to x plus c. So this is the dx derivative and this is integral. I said reverse process, so both will get cancelled. So you will have this is x plus c. So integral dx is equal to x plus c. Next, second one, integral k into dx. What is k? K is some constant. All the letters, all the numbers are constants. So some constant and a function is there. You take the constant outside, k into integral dx, that is kx plus c. Okay, it is kx plus c. And whenever some constant is there, suppose c, you are having 2x like this, right? Integral 2x dx. In k place we are having 2, right? K means constant. Constant means all the letters, all the numbers. In differentiation already we discussed. Constant means what is it? All the letters and all the numbers are said to be constant. So this is your constant. So whenever it is like that, you write constant outside of integral. Constant and some function is there. Function means any value in terms of x. You write constant outside and take that integral. Okay, that is the procedure. Whenever constant is there with the equation, with the problem, we can write constant outside. So kx dx. Okay, integral dx is nothing but x. So kx. After the completion, we have to write plus c. See, all the formulas plus c, plus c, plus c is there. So next most repeated formula in integration is integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. Okay. So that means suppose x is having some power. Here instead of n you can take x to the power of 6 dx or x to the power of 5 dx, whatever you can take. In the place of n we can take any power, right? In general we have taken n, but instead of n we can take any number there. So whenever we are having x to the power of some value, then its formula is x to the power of n plus 1 by n plus 1 plus c. Okay, so slowly you can get used to all these formulas, but most repeated formula is this one. Next, integral e to the power of dx is no change for exponential function. It is e to the power of x plus c. Next one, integral a to the power of x dx is equal to a to the power of x by log a plus c. Next, integral sin x is minus cos x plus c. Integral cos x is sin x plus c. Next, integral tan x dx is equal to log of secant x plus c. Integral cot x dx is equal to log of sin x plus c. Integral secant square x dx is equal to tan x plus c. Integral cosecant square is equal to minus cot x plus c. Like that, these are the formulas, right? So formulas means so slowly you have to write 2-3 times and say it loudly, and by applying the problem slowly you will get used to all these formulas. So all formulas we are having here, and here observe this formula. What is this? Inside the integral, whenever we have plus minus sign, we have to write separate integrals, just like our differentiation. I said whenever plus minus is there, take individual derivatives, take separate derivatives. Here also same thing. Inside the integral we are having either plus or minus. We can take separate integrals, right? Individual integrations we can take. Okay, so whenever plus is there, minus is there in the problem, we can apply integral for each and every term. Right. Next, this one is sin h inverse x, and this one also most repeated formula, integral f dash x by f of x dx is equal to log f of x plus c. One thing you have to remember, this is very lengthy chapter, and the remaining chapters in calculus also almost dependent on this chapter, so you should be perfect with the concept, right? So whenever if we want to solve, we have to take the symbol as like this, and compulsory the function into dx we have to write. After solving each and every problem, plus c must be there. Marks are there for that. We will check at the end what is the answer. In that answer whether c is there or not, either in 7 marks question or in 2 marks question. So this c, observe all formulas are having plus c plus c plus c. So throughout this chapter, after the completion of your problem, at the end we have to write plus c, right? Each problem contains integral constant. Okay, that is your integration. Now by taking the problem slowly, we will apply all these formulas. Okay, now take your first question. What is that first question? Find. Actually all the questions find, or sometimes they can ask evaluate. Evaluate these integrals. That symbol represents integration. Now onwards, right? If we stretch s, right? It becomes integral symbol. So come on, first question is evaluate that one. What is the given question for us? It is x cube plus 1 by x plus sin x into dx. Okay, so is equal to, I said, now only I said inside the integral, if we have plus minus, we have to take separate integrals. So if you observe any number of times, it can be not only 2 times, it can be any number of times. If we are having plus minus, right, we have to take separate integrals. So come on, it is nothing but x cube dx. I am taking separately for each and every term. This is separate term, this is separate term, this is separate term. In between these terms, plus minus is there, we can take separate integrals, individual integrals. So this one plus next, come on, second term we can take independently, and third term also we can apply the integral separately. Whenever plus minus is there in the question, we have to take separate integrals, remember. So slowly you are getting used to, you have to get used to our integration. Actually very nice topic this one, right? So come on, x cube dx. So now come to x cube dx. What is this? X to the power of some value is there. What I said, most repeated formula I said, whenever the power is there for x, it belongs to this formula. Integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. Come on, n place we are having 3. So if we apply this formula for this, what happens? X to the power of n, in n place we are having 3. So 3 plus 1 by 3 plus 1 plus. So you can ask, madam, in the formula C is there, now why you are not writing C? No need to take always for each and every term plus C plus C plus C. C means it is a constant. After adding all constants, we will get constant only. So first find out all the integral values. At the end, you write plus C. Getting my point? No need to write for each and every term plus C plus C plus C. Why? C is a constant. Here after this I will write, after solving this I will get one formula plus C. Again here plus C. Again plus C. What happens? It is constant. Constant plus constant plus constant is again constant only. So no need to write 3 times. Just if we have to write 1 time. So now come to the second one, integral 1 by x dx. So is there any formula? You got it? Integral 1 by x dx. Okay, it is not given, but it is again a standard formula. Integral 1 by x dx is log x plus c. Okay, you can add in the list of the formula. Integral 1 by x dx is log x plus c, but I am not writing again plus c. After completing the problem, we have to write plus c. Next, integral sin x dx. Is there any formula with you? Integral sin x dx. Yes, it is there. Integral sin x dx is equal to minus cos x, plus of minus, minus cos x. At the end of all the values, we have to write plus c. Compulsory in the answer, you should have plus c. Okay, so this is the procedure to solve the problem. Okay, so first you take that one and observe the given problem. Whenever plus minus are there, right? So you take individual integrals, you take separate integrals for each and every term. You can take your integral values and apply the formula. Go for the formulas, see whether standard formula form is there or not. If it is not there, we will reduce it into our formula form. But here all are nicely in our formula form. First one is this form, integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c form. And second one, integral 1 by x dx is, it is again standard formula log x, and integral sin x is nothing but minus cos x. After completing all the problem, we have to write plus c. It is compulsory. Then only you will get 2 out of 2 for this problem. Now come to the second question. What is your second question? Integral cot square, we are doing 2 marks problems, right? Integral cot square x dx. So go to the list whether cot square is there or not in our list. No, cot x is there, cosec square x is there, right? But we don't have cot square x. So if any problem is given in the form so that there is no formula, don't worry, just we will convert the problem into our formulae form. How we can convert? By our trigonometric formulae, cot square x can be written as cosec square x minus 1 into dx. Why we are writing like this, madam? Yes, we are having cosec square formula, isn't it? Integral cosec square x dx is there. That's why we converted cot square x into cosec square x minus 1. Whenever any problem is given in a way that it is not directly in any formula form, we will convert into another form so that direct formula form will come to us. So cot square x, there is no direct formula. Cot x dx is there, but cot square is not there. But there is one formula, integral cosec square x dx. So by our trigonometry identities, cot square x can be written as cosec square x minus 1. So we can write this as cosec square x. Whenever plus minus, we have to take separate integrals. Dx minus 1 into dx is dx only. Getting my point? Whenever inside the problem, inside the integral, plus minus is there, you take separate integrals. So cosec square x dx minus 1 into dx. So is equal to integral cosec square x dx. Integral cosec square x dx is minus cot x. And integral dx is, I said no, first formula, integral dx is x. Come on. So be attentive, slowly you will get used to these formulas. Your brain will get used to these formulas. So this is our second one. Okay. So now we will solve the third one. So what is the third one? Observe. What is that? Find the integral of, that symbol means it represents integration. Integral x plus 1 by x whole cube. Only x cube we can apply the formula. Only 1 by x cube we can apply the formula. But here it is given that x plus 1 by x whole cube. Okay. So x plus 1 by x whole cube means, third question, again 2 marks, x plus 1 by x whole cube, that is integral. Okay. So a plus b whole square form, a plus b whole square, a plus b whole cube form, a cube plus b cube plus 3a square b plus 3ab square. So come on, expand it. A cube plus b cube 1 by x cube. 1 cube is 1 only, x cube plus 3a square b, 3x, right? A square means x square. You consider this as a, this as b. 3a square b plus 3ab square, right? So is equal to, it is x cube. We have to take for this integral. We expanded just, this is a plus b whole cube form. So integral plus, we can write this as x to the power of minus 3 plus 3, 1x will get cancel, and here downwards will get cancel into dx. Just I simplified, not applied any integration. Till now just we simplified this one. We cannot take directly this value for integrals. That's why by applying the formula, what is that formula? A plus b whole cube. A cube plus b cube plus 3ab plus 3a square b formula we applied and simplified. Now if you observe, plus 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 inside the integration, if plus minus is there, take the separate integrals. Okay girls, if you are not felt interested for differentiation, don't give up this topic. This is again new topic, right? If I said reverse process means fear, don't leave this topic. This is interesting topic. Show interest, slowly you will get used to all these things. Okay, so come on, whenever plus minus is there, okay, so you take the separate integrals. So it is integral x cube dx, come on, integral x to the power of minus 3 dx, plus whenever constant is there, I said write constant outside. So here also constant is there. Constant means letters and numbers are said to be constants. 1 by x dx. So come on, observe carefully. This is your which form? Integral x to the power of n dx form. X is having some power, so we can consider that as integral x to the power of n dx. What is it? X to the power of n plus 1 by n plus 1. So where n place you are having 3. Here also where n place you are having 1. So come on, x to the power of 3 plus 1 by 3 plus 1. Okay, and this one, come on, x to the power of minus 3 plus 1 by minus 3 plus 1 plus 3 into x to the power of 1 plus 1 by 1 plus 1 plus 3 integral 1 by x dx is log x. After completion of all these things, plus c. Actually girls, if you are practiced and if you used to these formulas, within 2 steps you can write it, right? No need to write. Actually we are doing now only, we started our integrals, that's why I am explaining like this directly. Here you can write x to the power of n plus 1 by n plus 1, 1 plus 1 2, x square by 2 also you can write. Okay, so is equal to x to the power of 4 by 4. Here it is x to the power of minus 2, here minus 2. So plus of minus, minus we can write, and we can write this as 2, and x to the power of minus 2 means it comes downwards, right? Plus 3x square by 2 plus 3 log x plus c. Okay, so this is the answer for your problem. So now come to the fourth question. Fourth question is very easy. You consider this as homework. Madam, how we can do this homework? Very simple. Here you take your identity, trigonometric identity. What happens? 1 instead of 1 you take sin square x plus cos square x, and here instead of sin 2x you take 2 sin x cos x. So then you will have, what will be your value? You will have sin square x plus cos square x plus 2 sin x cos x we will have, isn't it? So instead of 1 we have taken identity. So a square plus b square plus 2ab, it is a plus b whole square form. So is equal to integral, it is sin x plus cos x whole square into dx will be there, square root cancel. Then apply your normal integral sin x dx plus integral cos x dx. You know the formula, integral sin x dx, integral cos x dx. Apply plus c. That will be the answer for your fourth question. Okay. So today you practice these problems and try to write the formulas 2 times and say it once loudly, but don't take pressure. Slowly you will get used to all these formulas. We are daily, actually this is very lengthy topic, so daily we have to use all these formulas. So definitely you can get all the formulas at the end of the chapter. Okay. So that's all for today. Have a nice day.